Can you hear me? Yes. Okay. Okay. We're discussing thermochemistry. Thermochemistry. What's meaning of thermochemistry? In thermochemistry, we mainly discussing how thermal energy involved for chemical reactions. What are the changes doing in chemical conversions, chemical reactions? That's the meaning of thermochemistry. Right? In thermochemistry, we discussed different basic terms. Different basic terms. We discussed. I will revise last week lesson. First, we discussed about yeah. First, we discussed the meaning of heat, right? The heat. Heat, you already know. Heat is the energy. Heat is a type of energy which is from always high temperature to low temperature due to temperature difference. Heat is energy type which is formed due to temperature difference. Then we discussed about work. We discussed about work. They are the basic terms in thermochemistry. Work, what's the meaning of work? The a measure of energy transformation, right? They are basic terms. Basic terms. Then we discussed about energy. Energy, what's the meaning of energy? What's the meaning of energy? The energy is the what? The work doing capacity, the work doing ability, or uh, work doing capacity actually. Yeah, the capacity to do work. Yes. Then we discussed about matters. What's the meaning of matters? Matters. What's the meaning of matters? Matters. Yeah, they are the basic terms. Matters mean any substance with occupied mass and volume in the surrounding, right? Mass and volume, right? Gases, liquids, and solids are the matters. Solid, liquid, and gases are the matters. There are three types: solids, liquids, and gases. Solids, liquids, and gases. Okay, then we discussed about very important things, very important basic things. The first one is thermodynamic system. What's the meaning of thermodynamic system? Thermodynamic system is a selected area, right? Selected area from the universe. If we think this is a system, sorry, this is a universe. අපේ විශ්වය, universe, universe. What is clear, right? Human. Okay. Today I'm using my phone because the camera has a problem. When narrow. Okay. Okay. That's our universe. This is our universe. And what's the meaning of system? The system is a selected area for whatever experiment, for any study. Selected area for a particular study. Selected area for a particular study is a system. Yeah, this is a system. This is a system. System. All definitions I gave last day. System is a selected area for a particular study. Study එකකට අපි use කරන select කරගන්න area එක, right? Selected area for particular study. Then what's the meaning of surrounding? Surrounding means except system. This is a system, right? Except system, other all area, the all remain area in the universe we called as surrounding. Surrounding. This is surrounding. This is surrounding. It is a surrounding. Then surrounding. Surrounding. Then what's the meaning of system boundary? This is a boundary of the system that we called as system boundary. System boundary. System boundary. System boundary is the separating surface of system and surrounding. System and surrounding. The separating surface. Separating surface of the system we called as system boundary. මෙයා තමයි boundary. Right. Okay. What are the examples for systems? Examples for system. If you got some reaction take place in a test tube. Simple reaction, chemical reaction take place in a test tube. Then this test tube is a system. This test tube is a system. Right? What is a surrounding? Except test tube, may test tube එක නැතුව, without test tube, other all area in the universe, other all surroundings are the surrounding or environment. Surrounding or environment කියලා කියනවා, right? Surrounding. Right? Now what is a boundary? What's the system boundary? This glass surface is the system boundary. I told this system boundary may be physical or imaginary one. Sometimes system boundary is a physical. It has a physical surface. Then in this test tube there is a physical boundary, right? Physical surface. But sometimes it is imaginary boundary. If you got, as example, if you got අපි මෙහෙම ගත්තොත් if you got some selected area from ocean එකකින් තෝරගන්නකො selected area from ocean for check the water quality or whatever chemical reaction, then you don't have physical boundary. You have only imaginary virtual boundary or හදාගන්නකො using satellite map, or we can use any technology to mark this boundary. Then you don't have any physical boundary. That was an exam question. It is this system boundary, not always physical. It may be physical or imaginary one. Okay, that's the last day lesson. Finally, I explained about thermodynamic system types. We discussed about 3 main types of systems, right? What are the systems? Open system, closed system, and isolated system. What's the meaning of open system? Open system is a thermodynamic system. Thermodynamic means heat changing system, right? Heat is not constant. Thermodynamic system means again thermal energies vary. That's meaning of thermodynamic system. Thermodynamic system mainly 3 types. Mainly 3 types. What are the types? Open systems, closed systems, and isolated system. Open systems, closed systems, and isolated system. Isolated system. What's the meaning of open system? Open system means this is a system, and except the remaining area is a surrounding. Open system mean energy and matter both exchange. Energy matters हुई දෙකම change වෙනවා. Change වෙනවා කියන්නේ it's exchanging. Exchanging mean part of heat energy and matter. Energy mean heat energy mainly. And other energy type. Matters mean liquid and gas. Liquid, solid and gases. Any substance, right? They are exchanging, leaving out and entering both. Okay, what are the examples for open system? If you got a previous test tube example, Mia, it's a open system. How it is open system? Energy enter to the system. Ne? Energy enter to the system and energy leaving out. Then energy exchange. And matters. Making gas release. Think this chemical reaction release carbon dioxide or whatever byproduct as a gas, then it is releasing. Matters exchange, right? Energy and matter both exchange systems are open systems. What other examples? If you got plant, plant open or closed system, open system or closed system. If you go to plant, yeah, it's an open system. And Nabil, are you okay now? Then go ahead and Q&A. Okay. Okay. Now this is last week lesson. Okay, last week we discussed very basic things of thermodynamics. You can go to the recording and note down the short note. Right, complete the short note. Hurry. If you got plant is an open system. If you're doing some experiment or some study of plant, the plant is the system is plant. Then this plant is an open system. Why we call it is an open system? You know, for photosynthesis, sunlight energy, sunlight is required. Then energy exchange. And for photosynthesis reaction, it's absorb carbon dioxide utilize and oxygen releasing and water absorbing H2O, water absorbing. Lot of matter exchanging, right? They are the matter exchanging with surrounding. Give me a second. Okay, matter exchanging with surrounding and energy exchanging. Okay, that's why the plant is an open system. Right. Let's move into closed system. What's the meaning of closed system? This is a system. Only energy exchanging, no matter exchange. That's the thing. Only energy exchanging, no matter exchange. Okay. Only energy exchange, no matter exchange. What are examples? Example. Okay, if you got closed sealed glass bottle, you have sealed glass bottle or sealed test tube. Now it's a test tube. The lid is sealed. These are reactants. They are reactants. This lid is sealed. Okay, then is there any energy exchange? Yeah, energy is exchange. Energy exchange, heat energy, light energy, it's going through this boundary, right? But is there any matter exchange? No, matter is constant. Matter is not exchanging. Matter exchange when back, right? They are the closed system. That's a closed system. This is a closed system. This is a system. This is a surrounding. This is a surrounding. It's always may exchange only energy, but not matters, right? Not exchanging matters, only exchange energy through the boundary. Energy exchange through the boundary. Okay. The energy exchange through the boundary. Okay, then what's the meaning of isolated system? Isolated. Isolated mean no anything exchanging. Isolated system mean this is a system. This is a system, no energy or matter, no anything exchange. Energy or matter, both not exchanging through the boundary. What are the examples? Another example you met. What are the examples? No anything exchange to the boundary between system and surrounding. No anything exchange. Yeah, close calorimeter. Seal calorimeter. No, seal calorimeter. What else? Isuru. What are the examples? No, Dinul. Universe is not a system. Universe is not a system. Universe කියන්නේ මේ the entire normally system is a part of universe. අපි selected area දැන් මේකෙන් think this is a entire universe. Part of small region is a system. මේ වගේව තමයි මම අහන්නේ. System is always yeah, it's me. Universe is correct, but what are the systems? System is not universe. It's different. System is a selected area for a study. The universe is entire. Yeah, thermoplast or vacuum blast. Yes, thermoplast or vacuum blast. Yes. What else? Yeah, styrofoam box. Styrofoam box means rigiform box. If you got rigiform box මොකද වෙන්නේ? rigiform box එකක් ගත්තොත් this type rigiform box, no energy exchange. If you got sealed rigiform box, normally transportation of ice and fish transportation, we use rigiform box. Why? It's an isolated system. It is an isolated system. No energy exchanging, right? No energy exchanging and no matter exchanging. No, if it is sealed, no matter exchanging. Taking energy එක යන්නේත් very low energy transformation ability. That means energy conduction ability very low to completely sealed battery. Yeah, battery, it's heating, no? It's heating, energy transformation. No, battery එක කොහොමද energy එක transfer වෙනවනේ? Energy is exchanging. Right? It's a closed system. Met me. It's a closed system. Battery is a closed system. Not isolated. Hi. Okay. This is the last week lesson. We discussed basic terms and three main types of systems. What are the types? open system, closed system, and isolated system, and there are examples and all definitions. Open system, energy and matter both exchange. Closed system, only energy exchange, no matter exchange. Isolated system, no energy or matter exchange. Okay, this is a summary. Okay, and we did some calculation last day, right? We did some calculation. Think this is the universe. Yeah, this is a universe and system boundary, surrounding and system boundary. Right. I told if we're doing some work on the system, surrounding doing some work on the system, then what happened to the energy level of system? It is increasing. That means doing some work on the system means the energy level of system is increasing. That we did a lot of calculations last week. Right? Initially, the system consists of 50 joules of energy. Initial energy level 50. Initial energy level 50 joules, right? 150 joules of work doing by surrounding on the system. Then what happened? 150 joules absorbed to the system. 150 joules absorbed to the system. May I add when? Then the work done by the system on the surrounding. The work done by the system on the surrounding. The system doing some work on the surrounding, it is 250 joules. 250 joules. Then if it is asking what is the internal energy change of the system, delta E of the system, what's the answer? I can among make it I matakaragan. Initially, the system consists of 50 joules of energy. 50 joules, right? The work done by the surrounding on the system, it is 150 joules. 150 joules. The work done by the system on the surrounding is 250 joules. What is the internal energy change of the system? Can you send me the answer? Initially, 50 joules of consist in the system. Initially 50 තියෙනවා, right? 150 joules done on the system by surrounding on the system, then absorb 150 joules and 250 joules release. That means the work done by the system on the surrounding. ඒ කියන්නේ work මොන හරි වැඩක් කරද්දි work එකක් කරද්දි system එකෙන් it's heat loss, heat releasing 250 joule. What is the internal energy change of the system? හරි හැමෝම දාන්න බලමු. ඉසුරු no. මේ බලන්න. Initially it consists 50. Work done by the surrounding on the system 150 joules. Then it's absorbing. It's absorbing mean it's increase up to 200 joules. 200 venom. Right? Increase up to 200 joules. then work done by the system on the surrounding. Again, some part of heat energy releasing, 250 releasing, 250 releasing. Then what is the heat amount contained in the system? Tibbe 200. The work done by the system is 250. What's the heat? The final energy? Minus 50, yes. Minus 50 joule is the final energy. The internal energy change means final energy minus initial energy. Final energy minus initial energy. Initial energy, right? Minus 50. And what is the initial energy? Initially, 50 joules. 50 joules. 50 joules. Then what is the internal energy change? Internal energy change minus 100 joules. Minus 100 joules. Understood? You met? Finally, change minus 100. Minus 100. Dinul, not minus 50. Okay, this is the thing with me. Initial energy 50. The system initial energy 50. 150 joules absorbed to the system. Then what is the energy level? 200. 200. Right? 150 plus 50, it is 200. 250 done on the surrounding. That means 250 released to the surrounding. That means 250 joules work doing on the surround. Then the final energy level 250. Sorry, final energy level 200 minus 250 is minus 50. Minus 50. The question asks what is the internal change between minus 50 and plus 50? The final it is minus 50. Initial energy plus 50. The internal change is minus 100. Okay. Humit, Tulen. Sanura. Humit, what? Hi. Let's move into today's lesson. Today's lesson. Okay, last day we discussed all past paper questions as well. What's the meaning of electricity, Humit? electricity cut. Okay, let's go to the today lesson. Write down the topic. Today we are going to discuss chemical reactions. Yeah, there are the types of system I already discussed: open system, closed system, and isolated system. Isolated system means it's separated system, no energy or matter exchange. They are separated systems. Okay. Okay, write down the next topic. Types of reactions based on heat change. Types of reaction based on heat change. Types of reactions based on heat change. Types of reactions based on heat change. Types of reaction based on heat change. Sorry, heat exchange. Sorry, heat exchange. Types of reaction based on heat exchange. Types of reaction based on heat exchange. This is a very interesting part, right? Types of reaction based on heat exchange. Based on heat exchange, we can classify chemical reactions. Chemical reactions. Chemical reactions based on heat exchange. Chemical reactions mean, I think you already know what's the meaning of chemical reaction. Chemical reaction mean reactant. As example, think A and B are reactants. Reactants convert into product like AB2. AB2. It's a product. They are the reactants. Reactants. They are the product. Products. By a chemical conversion, reactants convert into new product. The difference is the chemical reaction main characteristic, this reactant characteristics totally different from the product characteristic. The product is totally new substance, new chemical, right? That's the thing. That's the difference. In physical changes, no any chemical change. As example, in physical changes, ice solid convert into water. Water. Is there any physical chemical change? No. Ice mean H2O solid. Water also H2O liquid. It's only physical change. But the chemical reaction is chemically conversion. It's producing new product. Reactant characteristics and product characteristics are not same. The characteristics are totally different. Characteristic totally different. Example, think if you react HCl, HCl means hydrochloric acid. It's a powerful acid. Plus sodium hydroxide. Sodium hydroxide is a powerful base. This is an acid-base reaction. This type reactions we called as neutralizing reactions. Neutralizing reactions. Then it is produced. Products are like a product had in a sodium. Actually, during the reaction, when make the sodium ion and OH ion break down. Hydrogen ion and chlorine ion break down. Right? This sodium ion react with chlorine. Then it is produced sodium chloride mineral. sodium chloride mineral, right? And H and OH react, hydrogen ion and OH and react, then it is produced water molecule. Water molecule. Okay, this is a chemical reaction. Now you can see the reactants are acid and base. Reactants are acid and base. Product sodium chloride. Sodium chloride, it is neutral condition. It's not acid or base. Then water also neutral. That's why we this type reactions we called as neutralizing reactions. Neutralizing reactions. Neutralizing reaction mean neutralizing mean it's always in chemical reactions reactant characteristic totally different, totally change when they convert into product. Convert into product. Clear? Now, according to the chemical, according to the heat exchange, chemical reactions mainly two types. Chemical reactions mainly two types. The first one is exothermic reaction that you already know. Exothermic reactions. And the second one is endothermic reactions. Endothermic reactions. First, I will explain the basic of exothermic and endothermic reactions. Then we can discuss further calculations, right? What are the differences between exothermic and endothermic reactions? These chemical reactions, especially these reactants convert into products and its changes and behaviors we discussing in next lesson, kinetic chemistry, right? In this lesson we discussing basic things actually. Advanced discuss in the second lesson, kinetic chemistry, right? Okay, write down the first point. First point. The topic is chemical reactions based on the heat exchange, right? Then first point, based on the heat exchange, based on the heat exchange, based on the heat exchange, chemical reactions mainly two types. Chemical reactions mainly two types. Based on the heat exchange, chemical reactions mainly two types. First one, exothermic reaction. Exothermic reaction. The second one, endothermic reaction. Endothermic reaction. Exothermic reaction and second one, endothermic reaction. Okay, write down the first subtopic, exothermic reaction. Write down the first subtopic, exothermic reaction. First subtopic, exothermic reaction. Exothermic reaction. Exothermic reaction. Exothermic reaction. This is a very important part. Exothermic reaction. What's the meaning of exothermic reaction? It is simple. Exothermic reaction. Exothermic reaction. Exothermic reaction means while reactants convert into product, reactants convert into products, some amount of heat release to the environment. Release to the environment like this. Now, think in this lesson, we think the chemical reaction take place in a system, right? This is a system. The chemical reaction take place in the system, right? This is a system. In the system, reactants convert into products. Reactants convert into products. Some part of heat energy released to the environment. Think reactants like both 20 joules. 20 joules consist of reactants, right? If it is exothermic reaction, some part of heat energy released to the environment. Environment means surrounding, right? Surrounding. While reactants convert into products, some part of heat energy released to the surrounding from the system, right? That's the exothermic reaction. Okay, now think 5 joules released to the surrounding. Then what is the product energy level? Product energy level only 15 joule. I got. Okay, first, what's the meaning of exothermic reaction? Reactants convert into product, some part of heat energy released to the surrounding from the system, right? Some part of heat energy released to the surrounding from the system. Some part of heat energy released to the surrounding from the system. Heat energy released to the surrounding from the system, right? As result, what happened to the final energy level of the system? Final energy level, it is low value. It is low. It is less than reactant initial energy. Reactant initial energy. I got. It is very important. මෙතනින් ගොඩාක් questions ඇවිත් තියෙනවා. Exothermic reaction mean reactants convert into product. That's a chemical reaction. Some part of heat energy released to the surrounding from the system. Actually, then අපි හිතමු මෙහෙම. Now think the reactant contains 20 joules, 20 joules initial, right? Reactants convert into product, 5 joules released to the environment, surrounding. Then what is the remain? Remain only 15 joules. 15 joules, right? The remain only 15 joules. Reactant energy level 20, product energy level 15 joules. 15 joules. එතකොට මේකේ what happened to the energy change, energy difference, delta E. Delta E, the internal energy difference of the system, always it is minus value. Internal energy difference means final energy minus initial energy. Final energy minus initial energy. The final energy is 15 minus initial energy 20. It is always minus value. Delta E is always minus value. Understood? Okay, this is the nature of exothermic reactions. While convert reactants into products, some part of heat energy released to the surrounding. Oh, sorry. Okay, I got this story. The exothermic reactions. Reactants convert into product. While reactants convert into product, some part of heat energy released to the surrounding. May එළියට system එකේ, right? Okay. Okay, sorry. Is there any lagging in our video? Vihenga, is it lagging? Yeah, that's the point. Wait, give me a second. Okay, now okay, right? Thank Harne. Okay, so there was a connection. Hari, apparent. Okay, we discussed about chemical reactions. Chemical reactions. Okay, based on heat exchange, these chemical reactions, two types I told you, exothermic and endothermic. Okay, I'll explain again what's the meaning of exothermic reaction. That is very, very important. Try to understand this clear story, right? It's a very simple story. Okay, exothermic reaction mean okay, so everywhere power cut today, right? Well, exothermic reaction. Exothermic reaction. Exothermic reaction mean reactants, while reactants convert into product inside the system, some part of heat energy released to the surrounding from the system. Then what happened? The product energy less than the reactant energy always. Reactant energy greater than product energy because some heat energy released to the surrounding. As a result, always in exothermic reaction, the system energy difference is minus value. The energy change value is final energy minus initial energy. It is minus value always. Clear? This is exothermic reaction. Met me? Understood? Nabil? Hi. Okay, write down the first point. Write down the first point. Chemical reactions. Chemical reactions. Write down the first point. Chemical reactions chemical reactions releasing heat. Chemical reactions releasing heat. Chemical reactions releasing heat into surrounding. Releasing heat into surrounding. While reactants convert into products. While reactants convert into product. Chemical reactions release energy into surrounding while reactants convert into product. Is called as exothermic reactions. Is called as exothermic reactions. Chemical reactions release energy into surrounding while reactants convert into product. Is called as exothermic reactions. Is called as exothermic reactions. Second point. Second point. since energy released to the surrounding from the system, since energy released to the surrounding from the system, since energy released to the surrounding from the system, since energy released to the surrounding from the system, always product energy, always product energy less than the reactant energy. Since energy released to the surrounding from the system, always reactant energy less than the product energy. Sorry, product energy less than the reactant energy. Always product energy less than the reactant energy. Product energy less than the reactant energy. Third point. Third point. Third point. Since above, sorry, due to above energy difference, I mean, due to above energy change, 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 the delta E of the system, delta E of the system, delta E of the system, always minus value. Delta E mean energy difference of the system, always minus value. Always minus value. Okay, write down this one first. Make a lianda. Then you can draw this one and this one. Wait, Tunalia. Okay, complete. It's very simple. Reactants convert into products, some part of heat energy released to the surrounding from the system. එතකොට reactants final energy is less than initial energy. Due to that, always delta E value for exothermic reaction, exothermic system, always delta E value, again exothermic reaction take place in a system. A system take place an exothermic reaction, always the delta E value is minus value. Minus value. Delta E mean energy difference value is minus value. Okay, Dinul, clear? Ha. Delta E value is minus value. Hari. මෙන්න මේක ඔයාලා තේරුම් ගන්න. අපි system, what's the purpose of learning a system? Always in this lesson we think a chemical reaction, reactants convert into product inside a system, inside a thermodynamic system, right? Then then reactants contain 20 joules. Product some part of heat energy, while reactants convert into product some part of heat energy release to the surrounding. This is surrounding. Inside the universe, this is surrounding. 5 joules release to the surrounding, right? Then only remain inside the system, it's only remain 15 joules. That's why we call the delta E value. Delta E mean energy difference. Final energy 15 minus initially Tippa 20. That's why we call it is always minus delta E value, always minus for exothermic reactions. Remember, සෑහෙන්න අහලා තියෙනවා. හරි. Okay, what do you think? Now always heat releasing in exothermic reaction, always heat releasing. Then what happened to the surface? It is cooling. Oh, then අපි මෙහෙම test tube එකක් ඇතුලේ මේක වෙනවා නම්. Think exothermic reaction take place in a test tube. Then the test tube is a system. The test tube is a system. Okay, then the test tube surface is heating or cooling in exothermic reaction. අපි මෙහෙම මේකේ surface එක touch කරොත් what we can feel, it is heating or cooling. Now heat releasing, no? Heat releasing. Heat releasing. What do you think? Met me. What do you think? No, Vihan. Always in exothermic reaction, the surface is heating. Surface is heating. Hey, මෙයා heat වෙන්න මේකයි. මේ දැන් heat එක need to be exchange, heat need to be exhaust. Exhaust mean release. Release. Therefore, මෙයාගේ temperature එක මොකද වෙන්න ඕනේ? It is greater than in surrounding temperature. Right? Think surface temperature 50 joules. 50 Celsius and surrounding temperature 30 Celsius. That's why heat energy flowing this way. System to surrounding. I got heat always transfer from high temperature to low temperature. Therefore, the surface need to be heated always in exothermic reaction as due to the result of the chemical reaction, the surface of the system is heating. That's why part of heat energy released to the surrounding. Okay, get the full idea. In the exothermic reaction, actually that's the reason for some this heat lost. මේකට හේතුවත් මේක තමයි. මේකෙදි වෙන්නේ මේ surface is heating as a result of exothermic reaction. Due to that, the surrounding temperature less than surface temperature. Therefore, heat energy transfer from high temperature to low temperature. That's a reason for heat loss. Got Vihanga? Dino Sanura? Yeah. හරි. මේක එක දිගට යන කතාවක්. හරිද? It's not a very complex thing. It's a simple thing. හරි. Write down the next point, fourth point. Write down the fourth point. Due to heat energy flowing out from the system, due to heat energy flowing out from the system, due to heat energy flowing out from the system, the surface temperature of the system is, the surface temperature of the system is, the surface temperature of the system is increasing. The surface temperature of the system is increasing. Within bracket, surface heating. එහෙම තමයි අපි කෙටියෙන් කියන්නේ. Surface එක heated, right? Surface heating. Surface heating. Surface heating. Okay. Okay, this is the summary of exothermic reactions. Again, summarize what's the meaning of exothermic reaction. Exothermic reaction means reactants convert into product. Always we think reaction is take place in the system. Some part of heat energy released to the surrounding. Released to the surrounding. That's the meaning of exothermic reaction. As a result of that, the internal energy change become minus value that we call as enthalpy change as well. Enthalpy change I will explain later. මේකට අපි කියන්නේ enthalpy change කියලා, right? ඒක අපි පස්සේ බලමු. However, simply the energy change is delta E is minus value. Delta E is minus value. Delta E is minus value. And the surface temperature also getting increased, then surface heating. Okay, that's a summary. That's an exothermic reaction. Okay, write down the next topic. Energy diagram for exothermic reaction. Energy diagram for exothermic reaction. Subtopic, right? Energy diagram for exothermic reaction. Energy diagram. Energy diagram for exothermic reaction. Energy diagram for exothermic reaction. Okay, it is simple. Energy diagram. This is the x-axis and this is y-axis. Right. Now, x-axis, always any kind of energy diagram, remember x-axis is reaction coordinate. Reaction coordinate. Coordinate. Reaction coordinate. Reaction coordinate mean actually time, right? Time kiyalat kiyan, but actual name is reaction coordinate. Right? The y-axis is temperature. No, energy. Y-axis is energy. Y-axis is energy. Hari. හොඳට බලන්න. Right. The most important thing. Okay. Think this is the energy level of reactants and products. hari. දැන් මේකේ අපි මේක මතක තියාගන්නේ කොහොමද? හොඳට බලන්න. Now think in exothermic reaction, what happened to the reactant energy? Reactant energy is less than the product energy. Why? Sorry. Product energy is less than the reactant energy. Make reactant energy product. මේක පටල ගන්න එපා. මේක මතක තියාගන්න දෙයක් නෑ අතටම. හරිද? The exothermic reaction mean some part of heat energy releasing. Heat energy releasing. Then මෙතන 20 තිබ්බනම් 5 joules releasing, then product energy 50. Then product energy less than reactant energy. Right? Then always may යටට එන්නේ. This is energy level. Energy greater energy level is reactants. Reactants are the greater energy level. This is product. Products. Okay. Now this is the reaction direction. Reaction direction we can show by an arrow. Okay, this is the energy diagram for exothermic reaction. This is the energy diagram for exothermic reactions. How you remember that? The reactant energy is greater than the product energy since some part of heat energy released to the surrounding. Understood? This is the energy diagram. මේ දෙක decide කරගන්නේ එයාලගේ energy levels අනුව. හරි නේද? Any doubt? Parami? Hi. Okay. Draw the energy diagram. Make a දාගන්න. This. මොකද වෙන්නේ මේ product energy less. මෙයාගේ energy එක less than reactant energy. Reactant energy greater. The reason is part of heat energy released to the surround. හරි. මේකත් දාගන්න. මේක අඳින්න මේක ඉස්සරහින් ලියන්න. Okay, complete. It's the x-axis always reaction coordinate or time. Time kelapi time tama එතනට එන්නේ, but the specific name is reaction coordinate. You can remember reaction coordinate, and this is the energy level. This is the energy level. Always in exothermic reaction, reactant energy level greater than product energy level. And this arrow is the reaction direction, reactants to product. This is a reaction direction. Okay, write down the next subtopic: examples for exothermic reactions. Examples for exothermic reactions. Examples for exothermic reactions. Examples. Let's see what are the examples for exothermic reactions. What are the examples? Example for exothermic reaction. Okay, actually, more than 1,000 examples we can write down for exothermic reactions. Therefore, I'll give you as groups. Groups then number. Okay, that's an easy way. The first one, if you got any acid, right? The first one, any acid, right? Any acid, if it is react with base, definitely it is exothermic reaction. It can ඕනම acid එකක්. Think sodium, HCl මේ බලන්න HCl, H2SO4 sulfuric, HNO3, HNO3 nitric, HCO3 carbonic. එම ඕනි තරම් තියෙනවා acids, right? Not only that, CH3COOH acidic acid, right? Any acid, if it is react with any kind of base. What are the examples for base? Sodium hydroxide is a powerful base. Potassium hydroxide is a powerful base. Calcium carbonate is a powerful base. Calcium hydroxide. Calcium hydroxide is a powerful base. Calcium bicarbonate. Calcium bicarbonate also powerful base. Any acid react with any base. These type reactions are exothermic reactions. This type reactions we called as neutralizing reactions, right? Neutralizing reactions. Neutralizing reactions. Acid-base reactions. Acid-base reaction mean neutralizing reaction. Neutralizing reaction. Any acid-base reaction is a exothermic reaction. Okay, note down first one, acid-base reactions. They are the examples. Maybe what are the acid-base reaction? Any kind of acid-base reaction na exothermic reaction. Okay, write down first one, acid-base reaction, within bracket neutralizing reaction. neutralizing reaction. And write down examples. 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 Okay, second example. Second example. Can I guess? හරි අපි යන් second එකට මේ ඔයාලා දන්න ටිකක් ලියා ගන්න. හරිද? Second example. Then acid based all reactions exothermic. Acid මොකද වෙන්නේ මේ acid plus water reactions. What do you think? Acid plus water reactions. Acid react with water. අපි මේකට කියනවා dilution reactions කියලා. Dilution reactions. අපි acid වලට water දාන්නේ සාමාන්‍යයෙන් dilute කරන්න, right? Dilution reactions. Dilution reaction. Dilute කරන්න තමයි දාන්න. එතකොට මොකද වෙන්නේ? අපි සාමාන්‍යයෙන් what is the correct method to dilution? අපි මෙහෙම think get some think it is test tube and it's acid and we have water bottle. This is water bottle. It's water. හරි අපි තියනවා කියමුකෝ water in same type. It's water, right? Water. In the correct dilution process අපි මේකේ මොන side එකද කරන්නේ? Water add into acid or acid add into water? What's the correct method? මේකෙන් මේකට දාන්නේ මේකෙන් මේකට දානවා. Both dilution කොහොම දැම්මත් solution එකක් හැදෙනවා. Then what is the correct method? What's the correct dilution method? Met me, Sanula. Water add into acid or acid add into water? Very good. Water slowly add into water acid. Make අනිත් පැත්ත කරන්නේ නැත්තේ. That's I want. Sanula, what's the reason? අපි මේක acid water එකට දැම්මොත් මොකක් වෙයි? What happened if we add acid into water beaker, water test tube? No, we can get specific dilution. අපිට මේක we can measure the water volume and we can measure the acid volume and we can mix. No problem. It is not effective for dilution process. No problem. Sanula. අපිට measure කරලා දා ගන්න පුළුවන්. But why the recommended way is water add into acid? Why? Yeah, that's the reason. Made me very good. Sanula. The reason is they may acids. Small amount of acid if we add into water bath, this acid is rapidly react with all water amount. Then it is release huge amount of heat. Sometimes this test tube is blast make a pupurandura pulva. It's huge heat amount is releasing in a very small time. Therefore, it is very dangerous. Yeah, it's a highly exothermic reaction because normally HCl type acid is highly concentrated acid. No, it's highly acidic. අපි මෙන්න මෙයා කෙලින්ම මේකට දැම්මොත් it's highly exothermic reaction. It's very dangerous. Therefore, the recommended way is slowly add water into this beaker. මෙන්න මේ සාමාන්‍ය මේ wall එක දිගේ තමයි අපි දාන්නේ along the wall. Right? එකපාර මේකට දාන්න. It's very careful process, right? Carefully the water add into the acid beaker along the wall. මෙන්න මෙහෙම ඉමීට තමයි දාන්නේ. Right? එතන මොකද වෙන්නේ? It is slowly reacting. Slowly reacting. Water slowly reacting with acid. Then it's heat producing, right? But it's slowly producing heat. Then we can avoid damages to the glass tubes. I got. The reason is it is dangerous. It's producing huge heat amount within very short time. Then the large amount of water will be mixed, will be able to absorb heat. But mixing acid in acid water high it's not it acid adding into water. මේක කරොත් නේ අහන්න. Acid add into water, then the large amount of water will be able to absorb heat in. No, you asking reverse way, right? මෙහෙම කරොත් නේද අහන්න. Met me. Yeah, no. If we add acid into water, what happens is acid rapidly reacting with all water molecules. It is higher reaction rate, rapid reaction rate. Due to that, it's producing large heat amount. That's the problem. Large heat amount, very huge heat amount within very short time. That much highly reaction rate. Same reaction rate එකක් එනවා. Due to that, it's produced huge heat amount, heat quantity. That's the reason. Making release in heat, it is highly dangerous. That's why the recommended way is add water slowly into acid. Slowly add water into acid. එතකොට මොකද වෙන්නේ? Reaction is slowly take place, the reaction. Due to that, slowly release heat. It's exothermic. Slowly release the heat. Heat එක හැදෙනවා, but it is slowly release. Release වෙන තමයි අපි heat water add කරන්නේ. Right, Salva? Okay, then you need to understand these acid water reactions are all acid water reactions are exothermic. All acid water reactions are exothermic. Any acid react with water, any acid mix with water, these reactions exothermic. Hari. Write down the second one, acid water reactions. Examples. HCl plus water, H2SO4 plus water, HNO3 plus water. තව තියෙනවා මම ඔය ටිකක් දුන්නේ හරියට. තව තියෙනවා. Any kind of acid react with water, it is exothermic reaction. Okay, let's move into third one. What do you think base react with water? Base react with water reaction. අපි base එකක් ගමු, caustic soda. You know caustic soda? Sodium hydroxide. It's a powerful base, right? Caustic soda react with water. What do you think? Is surface heating or cooling? Heating, yes, heating. That one also same. That one also exothermic reaction. ඔයාලට මේක බලන්න පුළුවන් මෙහෙම. If you got washing powder, තියෙන්නේ මේ washing powders ඔය cloth washing වලට ගන්න රෙදි හොදන්න ගන්න කුඩු රේටිකක් අරගෙන add some small amount of water. අතට අරගෙන add small amount of water. Then it is what you can feel. Heating or cooling. Dino. Heating or cooling. What you can feel. Add small amount of water, right? It's heating. Good. Heating. කරලා බලන්න. Normally soap is a base. Soap is a not it's a normally 7.58 වගේ තියෙන soap powder, right? Normally if we add water into soap powder, it's releasing some heat. You can feel අපි වතුරකට දාලා දිය කරාට එහෙම රත් වෙන්නේ නැහැ. හරි. It's not highly base, it's slightly base. Hurry. Any base water reaction, that one also exothermic. Hurry. What else? Fourth one. Fourth one. Acid plus metal reaction. What do you think? Acid plus metal. As example, example එකක් විදියට ගත්තොත් example HCl plus sodium. Then it is produced sodium chloride and hydrogen gas. It is exothermic reaction. Any metal react with acid, that one also exothermic. The surface is heating. Surface එක heat වෙනවා. Right. What else? තව මේකත් එයා ගන්න fourth example, acid metal reaction. Not only that, fifth one. Burning reactions. Burning or combustion reaction, both. Combustion, same thing. මේක දෙකක් විදිහට අපි හිතනවා combustion reaction. Burning or combustion burning mean just react with oxygen in normal condition. Any substance react with oxygen. අපි හිතමු burning mean react with oxygen. Combustion mean react with oxygen in high pressure conditions. Normally within the engine pistons, it is students, within the engine cylinder, the petrol burning we call as combustion, right? Under high pressure conditions. Okay, that's a combustion and burning. Both are exothermic. Burn with the කොහොමත් heat releasing, right? Burning and combustion reactions, exothermic. Okay, another one. What do you think? Respiration. What happened in respiration? The respiration mean oxygen react with glucose, right? Glucose breakdown by oxygen. අපි respirate කරද්දී අපි oxygen අරගෙන glucose breakdown කරනවා. As result, it's release carbon dioxide and water vapor. H2O gas, carbon dioxide gas and water vapor. Then, and additionally, some amount of heat energy released to the. අපි දැන් මෙහෙම respirate කරද්දී අපි exhaust එකේ මොකද වෙන්නේ? It has some heat. It's release some heat. It's exothermic reaction. Okay, they are the examples for exothermic reactions. They are the examples for exothermic reaction. Right. මේවා අහලා තියෙනවා exam එකේ ඇති වෙන්න, right? අපි බලමු what are the exam questions. Let's see what are the exam questions. Right. The exothermic reaction is done. Right. Let's summarize again. What's the meaning of exothermic reactions? While reactants convert into products, some part of heat energy relates to the surrounding from the system. As a result of that, reactant energy less than the product energy, final energy less than the initial energy. Therefore, delta E value of exothermic system always it is minus energy value always. Any doubt in exothermic reaction? Any doubt? Then let's move into our next type of reaction, endothermic reaction. Then again we have discussed about endothermic reaction. Endothermic reaction. Write down the topic. Endothermic reaction. Endothermic reaction. Endothermic reaction. Endothermic reaction. Endothermic reaction. Okay, what's the meaning of endothermic reaction? Reactants convert into product. It's simple. Reactants convert into product. Reactants convert into product. Some part of heat energy absorbed into system. This is a heat energy absorbed into system. As example, if you got the reactant energy level 20 joules, 5 joules absorbed now. 5 joules absorbed. Then product energy level 25 joule. Product energy 25 joule. මේ වගේ. Think this is a system. Reactants convert into product. The reaction take place in the system. Reaction take place in the system. Part of heat energy release. Sorry, absorbing. Part of heat energy absorbed. 5 joules absorbed. Now reactants 20 joule, final energy greater than product energy. So reactant energy, right? Final energy greater than initial energy. Then what happened to the delta E value? Delta E value, energy difference always final energy minus initial energy. It's always plus value. Final energy 25 joule minus initial energy 20 joules. It's always the delta E always plus value 5 joules. It's always plus value for endothermic reaction. Are you good? Very simple. Right. Write down the first point. Chemical reactions. Chemical reactions. Chemical reactions. Absorbing some heat amount. Absorbing some heat amount. While reactants, absorbing some heat amount, while reactants convert into products. While reactants convert into products. While reactants convert into product. Second point. Since heat energy absorbed into the system, since heat energy absorbed into the system during the reaction, since heat energy absorbed into the system during the reaction, since heat energy absorbed into the system during the reaction, product energy greater than the reactant energy. 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 Third point, due to above energy change, third point, due to above energy change, endothermic reaction delta E, mean energy difference, endothermic reaction delta E always getting plus value. Endothermic reaction delta E always getting plus value. Okay, write down this one and this one and this one. Okay, Tanur. Nabil, complete. Okay, complete. Tinul. Okay. මේක හරිනේ. හරි. Okay. Now what do you think in endothermic reactions, the surface of the system, the surface of the test tube, think this is a test tube, and endothermic reaction take place in this system. What happened to the surface temperature? It's increasing or decreasing, heating or cooling, heating or cooling. It is actually vehicle. What happened? Endothermic reaction surface temperature, heating or cooling? It is cooling. Very good. The temperature, normal surface surrounding temperature 30 Celsius, right? As a result of endothermic reaction, the surface temperature getting 20, it decrease up to 20. That's why heat energy flowing from high temperature to low temperature. That's why heat energy absorbed into the system. That's why product energy greater than the reactant energy as a result of this temperature difference. Right? That's a story. All right. Write down the fourth point. Write down the fourth point. Due to the heat energy, flow into the system, into the system, the temperature of the system, the temperature of the system surface, the temperature of the system surface getting decrease, within bracket surface cooling, surface cooling. Hari, do you have any practical idea which type reactions surface cooling? Api glass එක cool වෙන්නේ, test tube එක cool වෙන්නේ. Do you have any practical experience? Which type reactions cool the surface, cool the test tube or glass? Which type reactions? මොන වගේ reactions වල the surface එක cool වෙන්නේ? Anyone? Any idea? Hari, එක හිතන්න. Write down the next topic, the energy diagram of endothermic reaction. The energy diagram for endothermic reaction. Energy diagram. Energy diagram. Energy diagram for endothermic reaction. Energy diagram for endothermic reaction. Same as previous. This one is x-axis reaction coordinate. Reaction coordinate or time. Reaction coordinate or time. This is the energy level. Now you can imagine. Reactants convert into product. Some part of heat energy absorbed into the system. 5 joules absorbed into system. මෙයාගේ 20 joules තිබ්බොත් product 25 joules. Products energy 25 joules. Then reactant to products higher energy level, final energy, product energy, right? එතකොට මෙතනට එන්න ඕනේ products. This is a product energy. This is a reactant energy. This is a reactant. Products. And this is the reaction direction. Reaction always take place from reactants to product. Reactants to products. Okay, this is the story. This is the energy diagram. Draw this diagram and energy diagram and this. No need to by heart. If you understood the way to draw the energy diagram, you can remember, right? Simple. If it is exothermic, reactants energy less, so reactants greater than products. In endothermic, reactants less than product. Okay, this is an energy diagram. Let's move into final topic. Examples for examples for endothermic reaction. endothermic reactions. What are the examples for endothermic reaction? What do you think? Do you have any idea, practical experience, which type reactions cool the surface? Which type reactions? Any example? Any idea? Cold in the surface. No, they are not chemical reactions with me. Parami. They are physical changes. You have to go to previous lesson. Parami. Then you can get the full idea. Physical state changes. Melting means solid water. What happened to a boat? Okay, now. Yeah, melting mean solid mean ice cube convert into liquid water. Solid also H2O, that's also H2O. Same. It's not a physical chemical change, chemical reaction. It's a physical state change. Current lesson එක බලන්න. What are the baking soda? Baking soda mean what is a chemical name? Baking soda base. Yeah, very good. Dinul correct. The photosynthesis is a endothermic reaction. Yeah, baking soda means sodium bicarbonate. Yeah, it is endothermic. Yeah. Cooking foods mean vinegar is acetic acid. Yeah. Yeah, mixing baking soda with vinegar. Yeah, acetic acid and baking soda reaction. Yeah. What else? Photosynthesis good. Photosynthesis is a endothermic reaction. What else? Yeah, pardon me. They should be chemical reactions. If it is physical changes, they are not chemical changes. Physical state changes, not chemical changes. Liquid. Met me. Liquid's evaporation also, it's a physical state change. It's not a chemical change. May any physical state change, not chemical reactions. I got me. Yeah. No, all heating reactions for me, they are exothermic. Heating mean burning, heating or burning. All reactions are exothermic. They release heat. They are the main endothermic reactions. Remember, they are the main endothermic reaction. The first one, main endothermic reaction. The first one, glucose. Glucose mean O6. It means glucose. Glucose packet if you dissolve in water, this reaction is endothermic. Glucose react dissolve in water. Glucose react with water. Glucose react with water. And do you know urea fertilizer? Urea fertilizer. Urea is type of ammonium mineral. Urea dissolved in water. That's also endothermic reaction. Endothermic reaction. Third one. Ammonium mineral. Ammonium minerals react with water. Ammonium minerals mean NH4 chloride. It is a type of ammonium mineral react with water. NH4 ammonium include hydroxide react with water. Ammonium include any mineral react with water. It is the Godaktina. You have to find out, right? You have to find out. Ammonium mineral react with water. That one also endothermic. Not only that, photosynthesis is a main endothermic reaction. That's why in the photosynthesis around plants, we can feel some cool environment, right? The photosynthesis is a cooling reaction. That means endothermic reaction. Photosynthesis. Okay, they are the main chemical reaction. I think you can remember what's the meaning of photosynthesis. Photosynthesis mean carbon dioxide. Carbon dioxide react with H2O using sunlight. Make sunlight use karna. Sunlight. Using sunlight. O6. That means glucose and it's heat absorbed, right? Sunlight absorbed. That's why we called as endothermic reaction. It's producing oxygen release. Okay, they are the main examples for you have to find out. This is your homework today. You have to find out more exothermic. You have to find out more endothermic reactions. ඔයාලගේ syllabus එකේ දීලා තියෙන්නේ මෙච්චරයි ඇත්තට. They are the all examples given in your syllabus. You have to find out more endothermic reactions. Okay, the first one, glucose dissolved in water, urea dissolved in water, ammonium minerals dissolved in water, and photosynthesis. Now, met me. Glucose react with oxygen mean it's respiration. Met me. It is exothermic. Make අනිත් පැත්තනේ එතකොට. The opposite way. It is exothermic. It's respiration. Right? It's exothermic. Any substance react with oxygen mean actually it is burning. නේද? අපි ඕනම එකක් oxygen එක react කරනවා කියන්නේ burning or breakdown. All oxygen reactions are exothermic. They are not endo, exothermic, heat producing, right? They are exothermic reactions. Okay, clear? In doubt? Okay, that's the end of theory part of this lesson. This is a very short lesson, right? It's very short lesson. The theory part is completed. Now you can find more exothermic, endothermic example. Then the theory part is completed. Next day we start the calculation of thermochemistry. That's the most important. Dark questions in a part, right? The calculations of thermochemistry. Start next day. The theory part of thermochemistry completed. Theory part. And after next week, yeah, we have 2 more weeks. Yeah, 19th and 26th, we can complete this lesson. Next month, we start our new lesson, kinetic chemistry. Kinetic chemistry. Within next month, we can complete kinetic chemistry. Right. That's the main chemistry lessons in our syllabus. Main chemistry lessons in our syllabus. Right. Okay, then let's meet next day. You can more find out about exothermic and endothermic reactions. I think now you have full idea what's the story behind exothermic and endothermic reactions, right? Let's meet next day, next week with final part of thermochemistry. It is calculation part. It is calculation part, the heat of reaction calculation, the most important part. A part miss කරගන්න එපා කවුරුත්. It is very critical part. Critical part. If you miss this part, it is very difficult to understand yourself. It is difficult to understand alone. Okay, let's meet next week with the final part of lesson. Goodbye.